Hi everyone, today let's do some practice of our pointer diagram, shall we? So initially, right, we have a variable called as a. Our a, right, have a value of 2. And then we have another variable called as b, and then the value is 10. And then we have a pointer, our pointer x, okay? So our pointer x, right, what we do is we label it with a center dot. Initially, our pointer x is pointing to null, okay? And then we have another pointer y. This pointer y, right, is also pointing to null, okay? And then we have another double pointer. Our double pointer, right, for easy to recognize, I'm going to use 2 dot. Initially, it's pointing at null also. And then we have another pointer t. Initially, it's pointing to null also. For this practice, right, you can assume, right, after each question, our AB, XY, and ST would reset to its default value, so we can test it again, okay? So let me show you what I mean. Initially, right, let's say we have x is equal to address of a. Initially, if our x is equal to address of a, so let me draw it, okay? This is our template. And then we are going to start solving our question in here. So initially, our x, right, our pointer of x is initially pointing at this null direction. So what we need to do is, we need to cross it out, right? And then we are going to pointing to a new direction. Then you need to look, where did it point to? It's pointing to the address of a. So where is a? Our a, right, is equal to 2, okay? So if it's pointing to 2, then this arrow is going to pointing at this direction, okay? Then this have complete the first line statement. The second line statement, right, is the reference of x is equal to b. If you dereference x, right, it means, right, follow this arrow. If you follow this arrow, right, one thing you need to keep in mind is you need to change the value inside here also, okay? Don't just only follow the arrow. Don't just follow the arrow only. You need to also change the value if you see a dereference x. So let's see. Dereference x is equal to b. What is b? The value of b is 10, right? So we are going to cross this out, okay? We are going to cross this out. So the answer is 10 in here. So in the end, right, what happened is the variable a would have the value of 10, okay? This is a simple introduction of our pointer diagram. So let's look at more complex one. Our question B, right? Initially, our s is equal to address of x. Our s is a double pointer. Our x is a pointer, okay? So it's going to be this question A, okay? This question A. So now we are solving question B. Our question B, right? Initially, let me erase this B to avoid confusing with the variable name, okay? So our question B, right? Initially, our S is a double pointer. Our double pointer, right, is pointing at null. So we need to cancel out the null, right? So we cross it. And then what happened? We need to point it to the address of X. Our address of X, right, initially is null, right? So it's going to be like this, okay? So it's pointing at this direction. So let's look at the second line. The second line, right, x is equal to address of a. Our x initially is null, so we are going to cross out this null because we are going to point to new address. We need to point at the address of a. So what is a? A is 2, right? So label it, okay? Label it. So initially our a is 2. So this arrow, right, we're going to point to this direction, okay? Point to this direction. And then let's look at next line. Our next line, right, y is equal to address of b. So our y, what is our y? Our y is another pointer. So we can erase this, We are solving b now, okay? We are solving b. Y is equal to address of b. So initially, right, our y would be a pointer, okay, pointing at null. And then when we need to point to another address, we cross this away, okay, we cross this away. And then it's going to pointing at the address of b. Our b is equal to 10, okay? Our b is equal to 10, and then this pointer is pointing at this direction. So we have solved this part. So next part, right, t is equal to s. It means, right, our pointer of t Let's draw it, okay? Now we have a second pointer, okay? Our second pointer, right, is going to look like this. Initially, right, is also null, okay? But we are going to point to new address. We cross this out, and then our t is equal to address of s. If it's equal to address of s, right, so it's going to point to this direction, okay? It's going to point the same direction as s. So let me show you. It's going to be pointing the same direction as s, okay? So the arrow will be something like this. So let's look at this one. The reference t, right? So let's follow one time the reference, and then second time the reference. So we are at this position now. And remember, right, you not only just want to follow, you need to change the value when you see a dereference t, okay? So dereference t is equal to 2, this one is 2, okay? So when we follow it, right, the answer is 2 multiplied with dereference y. What is dereference y? If we follow dereference y, right, the answer is 10, okay? So 2 multiplied by 10, right, the answer is 20. And remember, I said just now, when you are doing a dereference, right, you not only need to follow it. What you need to do is change the value inside here, okay? So in the end, right, our variable a will have the value of 20, okay? Now let's look at question C. Our question C, right, initialize integer I. Why it need to initialize integer I outside here? Because this is a C89 standard. Integer I, x is equal to address of A. So let's draw our x first. Our x is a pointer, okay? Our x is a pointer. Initially it's pointing at null, and then we need to cross it out, okay? Cross it out. After that, right, x will point at the direction of A. What is direction of A? Our A is equal to 2. So we draw our A first, okay? This is A, this is 2, okay? So this is pointing at this direction now. And then our y, right, is pointing at the direction of B. So let's draw it. So our pointer y, right, have a box like this. Initially it's pointing at null, right? Then we cross it out. And then, right, it's going to point at this B, okay? This B have the value of 10. So the arrow is pointing at this direction. And then next, right, for I is equal to 1, then I is less than equal to dereference x. What is dereference x? If it's dereference x, right, this is 2, okay? This is equal to 2. So if I is less than equal to 2, then we need to increment it. So let's look at I. Our I initially is 1, okay? From 1 less than equal to 2, so we need to execute 1 time, execute 2 times, okay? So we are going to find the value of this one. Initially, in the first cycle, right, we dereference y. Dereference y, so we follow it, okay? So this 10, right, will equal to dereference again, dereference again. 10 multiplied by 2, so it's 20, okay? In the first loop, right, the answer is 20. So let's cross this out, okay? When we cross this out, right, this value is 20. We are not yet done, right? We have a second cycle. If you have a second cycle, right, then it's going to continue. We dereference y again. If we dereference y, right, we get the 20. B, our variables b multiplied by our variables b is equal to dereference y is equal to 20 multiplied by 2. So its answer is 40, okay? So it's 40, right? We write down the answer first, and then we need to cross this out and write 40, okay? So in the end, right, we look 2 times after we finish. I is equal to 3 after we increment it. 3 is less than equal to 2. The answer is false. Then we need to stop it. So in the end, right, the variable b will have the value of 40, okay? Let's look at another example, okay? Another example, x is equal to address of b. So x, right? So let's draw it, okay? Our x initially is pointing at null, right? We are going to cross it out. And then we are going to point to the address of b. What is b? Our b is 10. So our b initially is 10. We're pointing at this direction. And then secondly, right, we have our y. our y is also a pointer. Initially it's pointing at null, right? We need to cross this out. Then it's going to point to a. The a will be 2, okay? Our a is 2. Then later, right, t is equal to address of y. Our t is a double pointer. So our t would point at address of x in here, okay? Our t is a double pointer. Initially it's pointing at null, right? We need to cross it out. And then, right, our t will be pointing at the address of y, okay? If you are pointing at address of y, right, then t is equal to address of y. So it's going to be like this, okay? It's going to point in this direction. It's going to point at the address of y. Next. And then we need to dereference t. If we dereference t, right, we are in this position now, okay? And remember, if you are dereferenced, right, you need to change the value inside. Dereference t is equal to x. Dereference t is equal to x. What happened? You need to point to this direction, okay? You need to point to this direction. So if you point to a new direction, right, we are going to cross out the old one, right? Then we are going to point a new direction to like this, okay? And then if dereference t, right, dereference 1 time, dereference 2 time, if dereference t is greater than 5, yes, 10 is greater than 5, and then s is equal to t. So what is s? Our s is another double pointer. So we draw a new double pointer, okay? S, initially our double pointer is pointing at null, right? Then we need to cross it out. Then our s is pointing the same address as t. So it will point at the same direction as t. So it's going to be like this, okay? Pointing at the same direction. So it will point at this direction, okay? And then, right, we don't need to look at the else part because we already execute this line of code. So dereference s, right? Did we dereference 1 time? We dereference 2 time, okay? Dereference 1 time, dereference 2 time, okay? Here. So what is the value of dereference? The answer is 10. The answer is 10, okay? 10 divided by dereference of x. What is dereference of x? Our dereference of x is also 10, okay? So 10 divided by 10, the answer is 1, right? And remember, you not only need to count, you need to set the value, okay? So we dereference in here, right? Initially is 10, right? We need to cross it out, become 1, okay? The final answer is 1. So the variables v will have the value of 1, okay? Let's look at question E. Question E is a bit special. Question E, right, we need to see a new thing called as malloc. So let's look at the example. Our x, our y is a pointer, okay? Our x and y is a pointer. Initially we malloc it, okay? So let's draw out the diagram. So initially, right, we have a x pointer. Initially it's null, right? So we need to cross it out because we need to assign it to a new address, okay? And then this is a y, okay? Initially it's pointer also. So we need to cross this out, okay? So if you want to malloc it, right? If you want to malloc it, what you do is you draw a blank box, okay? Just for convenience, right? I'm going to label it as malloc, okay? I'm going to label it as malloc. This is a new memory address, okay? The new memory address, right? These two address is not same, okay? So our x is pointing to this memory address, and then our y, right, is pointing to this memory address. So we have finished our through line here, okay? And then we dereference x, right? If we dereference x, we are going to follow this direction, and then we are at this position. At this position, right, we assign at inside here. So we assign at inside here, and then let's look at the next line. The next line is also assigned at inside here. So we assign at inside there, right? What happened is, in the next line, right, you're going to compare if x is equal to y. Is the address of x same as address of y? The answer is no, okay? Answer is no. So we can skip this part because x is not equal to y. address is not same, yeah. The address of this one is not same as address of this one. So let's look at this part. If the reference x is equal to the reference y, so let's look at the reference. If we dereference right, we get the value, which is at. And then we dereference y right, the value is at. If at is equal to at, the answer is b would be the reference of y. What is b? Our b initially is 10, right? So let's look at it. Our b initially is 10, right? The value will become the reference of y. What is the value of y? The value of y is equal to at. So our variables b will have the value of at in the end, okay? Let's look at the last question. Our last question, right? We have a variable s. Our variable s, right, is a double pointer. Our variable s would have an double pointer malloc, okay? Because why we need to cast it to our integer double pointer is because our malloc, right? If you look at the code of the malloc, what they do is it malloc a void. Then what you need to do is malloc it to void. You need to typecast it to double pointer so we can assign the direction to this blank area, okay? So let's look at what do we mean. Initially, right, we have our s. Our s is a double pointer. Initially it's pointing at null, right? So we need to cross it out. And then what it do, right, in malloc, okay? In malloc. So let's label it malloc, okay? When in malloc, right, this is actually a pointer. Our s will have this direction pointing at this malloc. This is what I mean, the first line. And then the second line, right, our dereference s, right? If we dereference s, we are in this position. Our dereference s is equal to integer malloc size of our integer. This integer pointer, right, is to typecast another one, okay? Another one. Example, right, our malloc is like this. The second malloc, our second malloc is an integer, okay? Our second malloc is a regular integer. So initially, right, this data type is void. What we need to do is we need to typecast it to our integer pointer. So if we typecast it to integer pointer, right, so our malloc can point to this address, okay? Because we need to have a same data type for it to pointing at the same direction to store the same address. So after we finish our second part, right, let's look at this. So our t is equal to s. Our t, right, our t is another pointer. So let's draw it out. Our t is also a double pointer. Initially, right, it's null. So what we need to do is we need to cross it out, okay? Cross it out. And then it's going to point at the same direction as s. If it's going to point the same direction as s, right, it's going to point in this direction, okay? After that, right, let's go to the next line. And then, right, x is equal to address of t. What is x? Our x is a pointer. So let's draw our x, okay? So our x, right, initially is also a pointer. Our pointer initially is null also. We need to cross out the null. Initially, right, let's look at x. X is equal to the reference t. When you dereference t one time, right, it's in this position. In this position, right, so we set our dereference t is equal to x. Our dereference t is equal to x, right? Then x is going to point to the same direction as this one. So it's going to point in this direction. So in the end, right, it's going to point at this direction, okay? When you point in this direction, right, let's look at the next line. Our dereference t, our dereference t, right, in this position now. It dereference one time, dereference two time, okay? It's in this position. Our dereference t is equal to b. What is the value of b? The value of b is equal to 10, okay? So we store 10 to this empty space. After that, right, let's look at the next line. Our next line, right, s is equal to new integer, new integer. So let's draw a new box, okay? So we have a new box, okay? Our new box is a pointer. This is a malloc, okay? Malloc. In this box, right, the data type is integer, okay? So it can point to this direction. So after we cast it, we can point to this direction. And then right, all address right, all we need to do is we need to cross it out. Okay, cross this out, this address. So when we cross it out right, we can ignore this. It's pointing to this new direction now. So let's look at the dereference S. When we dereference S right, we are looking at this direction. Okay, we are looking at this direction. Our dereference S is here. Our dereference S will be storing of address of A. What is A? Our A is this one. Okay, our A is equal to 2. So this would point at this direction. Okay, our this malloc would pointing at this direction. Okay, then let's look at the next line. Our dereference X right. Our dereference 1 time, dereference 2 time. Okay, our dereference is equal to dereference X. What is dereference X now? Keep in mind, we are looking at this position now. If there are 2 dereference right, we need to change the variable value. Okay, we need to change the variable value. It's equal to dereference X. Dereference X is 10. Okay, if dereference X is 10 right, so we need to cross out this value and then store 10 inside. Okay, store 10 inside. So this is the final answer. So in the end right, the variable A will have the value of 10. Okay.